In this example, CDF is given and asking PDF. Okay, how do we find the PDF? We know it is FYY. This is equal the derivative of CDF with respect to Y. So you can use quotient rule or chain rule. So let me use the quotient rule. 1 plus e negative y, then derivative of y is 0 minus 1 time derivative of the denominator, right? So the derivative of the denominator is negative e negative y, then multiply by 1 because derivative of the power. So then divided by 1 plus e negative y power 2. So you can simplify, then this is e negative y 1 plus e negative y power 2. So how do we write the PDF in the standard form? So this e negative y 1 plus e negative y power 2. This is true for negative infinity to positive infinity. Negative infinity to positive infinity, otherwise it is 0. So part B, calculate the probability. Okay, how do we calculate probability when we have CDF? First, let me explain how to calculate probability when we have PDF. Okay, PDF. I just explain how to do it. So this is probability negative 2y 2. So this can be written using the integrals negative 2 to positive 2 and f y y f y y f y y dy, right? So we know f y y, so you can plug it e negative y 1 plus e negative y power 2 dy. So this is the probability negative 2 and 2, negative 2 to 2, but you have to integral this one, right? So you can use I think substitution method to integrate, but there is an easy way. When you have CDF, it is easy to get the probability. So what is actually let me explain using this. Okay, so this is the one you can integrate here, but let me tell you like this. Actually this negative 2 positive 2. Okay, this is the interval we consider. Okay, I write this one this way, from negative infinity to positive negative infinity to positive 2. Okay, and I write down fyy here, so you can write if you need the formula. Then that means negative infinity to positive infinity is from here to here, right? Positive 2, sorry. Then I write negative infinity to negative 2 and subtract. I think you understand. So this one negative infinity to negative 2 fyy dy. So you see, now we get the same one here, right? Like this. This equal to this difference of these two, right? Okay. Now what is this? You know, fyy equal py less than or equal y. So if you write down this negative infinity to y Fy dy. So that is the CDA. That's the definition. So consider this one. This is negative infinity, yes. And instead of y, we have 2. So therefore, here actually, here y, then this is y. So therefore, we can write this part fy2 minus fy negative 2, because this is the fy negative 2. Now you know fyy. So let me go to the top and erase this. So right, so let me then write down again probability negative 2 y2 now equal fy2 minus fy negative 2. So you see now here this is fyy, right? Fyy. So fy2 you plug the 2 for y, 1 over 1 plus e negative 2 minus 1 over 1 plus e negative 2. You see that? So it becomes positive anyway, right? So you can simplify. So if you use a calculator, you can have 881 minus 0.119 and this equal 0.762. Or for the test, actually you can simplify this like this, get in common denominator 1 plus e2 because of positive 2 here, and minus 1 minus e negative 2 here, 1 plus e negative 2, 1 plus e 2. So similarly you see, here cancel out. So e2 minus e negative 2 and divided by this. So you can leave that way too.